All right, here we are with Chapter 1, Section 4 on compositions. And I'm going to start us off with the notation. There are two different notations for a composition. Both of them mean the exact same thing. So you see right there, the first one, that little circle, that's the symbol for composition. So that first one actually says, in words you would say f of g of x. So it's like the little circle means the word of. Now the second notation I actually like a lot better. You'll see in just a second. It shows you exactly what you're doing. But it means the exact same thing and it says the exact same thing. It says f of g of x. So that's how you read that. If you see either one of those notations, although the letters could be switched around, we could do g of f of x, we could do h of k of x, you put any letters you want in there, but that's how you say them. First letter of second letter of x. Now what it means when you're doing a composition means you have two separate functions and you're actually taking one function and plugging it into the other one for x. Now with both notations, you're always plugging the second function into the first function. And I said here for our notes, we're plugging g into f. But don't think to yourself, okay, composition means you always plug g into f, because the letters change, and I can flip them around. So let's start off with an example of compositions. And I've given you two functions, f of x and g of x. Let's find f of g of x. So if I wanted to find f of g of x and I was given the two functions, the first thing I'm going to do, I'm going to look at the first letter, which in this case is f, and I'm going to start with that function. So let's just flat out copy down the function straight out of the problem, the first one listed. In this case, it's f of x. Now, when I wrote the question, I used the circle notation. I said find f of g of x. And I told you guys I actually like the second notation, the function notation one, better because it shows you what you're going to do. So for this question, I'm going to flip it back to function notation. And basically what I mean by that, just so we're all real clear here, I asked you guys to find f of g of x, but when I found it, I used the other notation, and that's perfectly fine. You are definitely allowed to switch notations in a question. Now, the reason I like function notation better, think back to Chapter 1, Section 1, our very first day of notes for this year. We were talking about function notation. I said, okay, let's find f of 3. You said, okay, great, I'm just going to plug in 3 for x. And then I said, now let's find f of x plus 2. And you were plugging in x plus 2 for x. Well, that leads to this question, because what I told you on that day and what we're still doing right now, function notation says whatever you see inside the parentheses here is what you substitute for each x in the question. And that's where I got what you see written below right there. I said for each of those x's, what I'm substituting is g of x. Well, g of x is x minus 1. So I put g of x here, and I put g of x here. So I have x minus 1 squared plus x minus 1, and then we still have that plus 3 on the end. And then you just multiply and clean things up. So when I square the first one, I get x squared minus 2x plus 1, and I just left the rest for now. I left x minus 1, and I left plus 3. And then I just combined my like terms. So I had an x squared, nothing to combine it with. I left that as part of my answer. I had a negative 2x and a positive x, or a positive 1x. So that gave me negative 1x when I combined those. And then I have a 1 and a negative 1, which actually cancel each other out. You can do this if you want. I'm adding a positive 1 and a negative 1. Those cancel. So basically, I just still had that plus 3 on the end. So my final answer is x squared minus x plus 3. And that's how you do a composition. It's really just function notation. You're plugging one function into the other for x, and then you're cleaning it up. Now what I want to do real quickly is let's do a second part. You can call it part B if you want. Basically, second part of the same example, same two functions, same f of x and g of x. This time I'm going to flip the letters around because I told you you can't just always plug g into f. You have to read the question and make sure you're doing the right thing. So when I asked you to find f of g of x, I was saying plug g into f. Now I'm asking you to find g of f of x, and I'm doing the opposite. I'm asking you to plug f into g. So to do this question, instead of starting with f of x, I would start with g of x. I'm still going to switch to function notation, because like I said, I like that better. So I'm asking you to find g of f of x, which remember means whatever you see inside the parentheses here, this is function notation, this is 1.1 stuff, you're going to substitute for x. Now this is actually a much easier substitution. There's only one place to put it, and we don't even have to do anything to it, it's just x. So basically this time I took the whole function f of x, and I put it in for x. So all I really have to do is subtract 1 from it. And we're done in one step. You just combine the positive 3 and the negative 1 to give you a positive 2. So final answer for this one is x squared plus x plus 2. That was a little easier than the first part, an easier substitution. But one very important thing for you guys to notice right now, we did not get the same answer. So compositions are not what we call commutative. That's the word for it. So with multiplication, multiplication is commutative. 3 times 2, 2 times 3, doesn't matter. The answer is 6. Same with adding. 3 plus 2, 2 plus 3, doesn't matter. The answer is 5. But compositions, it's very important that you do them in the right order because they're not the same. F of g of x and g of f of x they can be, but they're very often not the same. All right, so there's one last thing I want to talk to you guys about. This part that we just did was a review for you guys. You've definitely done compositions before. What I'm about to tell you is probably new for this class. So we're going to talk about domain of compositions. We talked a little bit about domain in 1.1, but when you're doing domain of a composition question, there's this weird thing that happens that you have to look for. It's very tricky. You have to know to look for it. You have to remember to look for it, because sometimes it can mess up the answer. So here's the concept. Let's say I do a question just like the ones we just did. I find f of g of x or g of f of x, it doesn't matter. I find a composition, and I want to find its domain. You actually have to check the domain of 2 different things. So number 1 is the obvious one. If I ask you for the domain of f of g of x, check the domain of f of g of x. And remember, when I say domain, remember from 1.1, you're asking yourself, what can x be? And for right now, we said there's only 2 things that can cause a problem: a denominator of 0 or a square root of a negative, an even root of a negative. All right, so you check the domain of f of g. Here's the weird part. You always have to check the domain of the second function. So you go back and you look at the original problem, whatever function was listed second. In this case, it would be g, but remember, it's not always g. The letters change. You have to check the domain of that one too. And the reason is, anything that didn't work in g couldn't later be plugged into the composition. And when we do our example, I have an example of this trick, this weird thing happening, and I'll explain why it might make a little bit more sense. I will say that you only have to check the second one. Whatever the first function is listed, f, if something doesn't work in f of x, it automatically also won't work in f of g of x. So you don't need to recheck that, but you always have to think about that second one. So I'm going to do one last example with you guys today, and I'm going to show you how that domain thing works out. So here are our 2 functions this time. We are going to find f of g of x, but this time we're also going to find its domain. So let's first of all do the composition. Just like our first 2 examples today, let's just find f of g of x. So when I'm doing this, we take the first letter, f, and we copy down that function. So I'm just going to start off with f of x equals x squared minus 9. And then what I've asked you guys to find is f of g of x, which means I'm going to take g of x and I'm going to put it in for x here. So basically, I'm going to take this function here, put it here, square it, subtract 9. So I'm going to have the square root of 9 minus x squared minus 9. And I look at it, and when I start to clean it up, I go, well, one thing happens that's really nice. We have a square and a square root that are going to cancel each other out. So this squared and this square root cancel, and it leaves us with just a ordinary, regular 9 minus x squared. And then I look at it and I say, well, now I don't really need those parentheses. I put them there, but you don't need them anymore. What I have is a positive 9 and a negative 9, which also cancel out. So my final answer is just a nice, simple negative x squared. Now, if I ask you guys the domain of that function, we would say all real numbers. So remember, as a refresher from 1.1, for domain questions, you're asking, is there anything that can make a denominator equal 0? And you say, well, this function doesn't even have a denominator, so I don't have to worry about that. Is there anything that could make a square root negative? This function doesn't have a square root. So the domain of this thing right here is all real numbers. And that symbol I just used, a capital R with a double bar, 2 lines on it, that's a symbol for real numbers. That's an easy shorthand notation for you guys. If you ever want to say real numbers, do a capital R with two straight lines on it. Now, that is not the answer to our question. The domain is not all real numbers. So let's talk about why. Clear some space here. So here's our original problem and the answer we just found. We had our original f of x and g of x, and we have our f of g of x. Well, one of the things I told you guys is we have this weird trick where in order to find the domain of f of g, you have to check the domain of f of g, which we just did, but you also have to check the domain of this one. So let's do that. If I wanted to do the domain of g of x, I look at that and I say, well, that one does have a square root. So that one is going to have some domain problems. Now remember from Monday or Tuesday when we did 1.1, I said if you have a square root, you need to make sure it's not negative. You need to take the thing inside the square root, 9 minus x squared, and say we need that to be greater than or equal to 0. Greater than or equal to 0 means not negative. So less than 0 is negative. Greater than 0 is positive, equal to 0 is equal to 0, and both of those are fine. So what I would do is, if I add x squared to both sides, cancel that out, we have 9 is greater than or equal to x squared. Take square root, and what you get, remember whenever you take a square root, you get a plus or minus. So instead of just 3, we get both positive and negative 3. Now, what we have here, once you find this answer, this is a review on what are called quadratic inequalities. Inequality means either less than or greater than. Quadratic means you have an x squared in it. So what happens in this question is once you get those two values, 3 and negative 3, then you know your domain is either going to be everything between those two numbers or everything on the outside of those two numbers. So you go, well, let's try one. Like a number between 3 and negative 3 would be 0. So if I go back up here to my function, if I plug in, I'm sorry, I'm not working on that one. We're actually looking, let's switch colors, we'll look light blue up here. We're looking at this one. If I plug in 0, it's fine. Because if I plug in 0 for x, I get 9 minus 0 is 9, square root of 9 is 3. That works perfectly. So let's try something bigger than 3, like if I plug in 5. If I plug in 5 for x, 5 squared is 25. 9 minus 25 is negative 16. I can't take that square root anymore. So what that tells me for my domain, is going to be all the numbers that are between 3 and negative 3. So it can be 3, it can be negative 3, it can be any number in between, but anything that's bigger than 3 or less than negative 3 does not work in this problem. And if it doesn't work here in g of x, then it doesn't work in f of g either. So here's the weird thing. So let's talk about number 5. You know, I showed you why 5 doesn't work. Well, if I ask you to find f of g of 5, let's say I asked you guys to find f of g of 5. And you say, okay, well, I'm just going to use this formula here and plug in 5. You would have negative 5 squared or negative 25. And you'd go, okay, I got an answer. It's negative 25. That's actually not the answer. That's wrong. And the reason is, when you're doing a composition, you're actually doing a shortcut where you're doing 2 steps at once. So this original question here, when I asked you guys for f of g of 5, what it really means is plug 5 into g of x, get an answer, then plug that number into f of x, and that'll give you your final answer. Well, see that when you try to do it in 2 steps, if I plug 5 into g of x, it doesn't work, and I have nothing to plug into f of x. And that's that weird domain thing. It's a very difficult concept. It's definitely, I mean, we've only been working together for 1 week. This is definitely the hardest thing we've talked about so far. So try to understand that concept. And as far as work, just remember, if you're ever asked to find the domain of a composition, you have to check 2 domains, the 2 that are circled right now, the one circled in purple and the one circled in light blue. In order to give the answer, you have to check the domain of both of those. All right, I hope that helped you guys out. As always, if you have any questions, email me, and I will see you guys in class.